Okay, to determine the electric field pattern around any of these charge setups, you need to pretend to be a positive charge. So if you're a positive charge right next to this positive charge over here, it will be like a radial field, it will be pushed away from the positive charge. So right next to any point charge, you'll get a radial field. Here you'll be attracted, if you're a positive charge, towards. On the center over here, you'd be pushed away from the positive charge and be pulled towards the negative charge. So the overall force in the center would be towards the right. Here in the center of this point here, you'd be pushed equally in both directions. So total resultant force at this point is 0. So the electric field strength at the center between the two positive charge will be 0. Anyway, if you're right next to the surface here, you'd always be pushed away from the surface at 90 degrees. So whenever the field line touches a surface or a charge, it's always at 90 degrees to that surface. And of course here it will be a radial field and it will point towards the radial field. When you draw it, you should draw it a lot more accurately and making sure it's 90 degrees. And it doesn't go inside the charge, it just touches the surface of the charge. Overall, the field pattern looks a bit like this for these setups. So the key things to keep in mind is that the equipotentials are always at 90 degrees to the field lines. So for example, at any point you draw, you need to make sure that you draw the field lines and equipotentials at 90 degrees. If it's not, you're probably doing it incorrectly. So for example here, I would personally make sure I would draw it at 90 degrees. This diagram is not doing a great job doing that. Another key thing to keep in mind, here we said that the electric field is 0. Just because the electric field is 0 here doesn't mean the electric potential is 0. So here there will be an electric potential value, but it won't be 0. And similarly here, it turns out the electric potential along this line, the potential here, is 0, but doesn't mean the electric field strength is 0. So electric field strength and electric potential, just because one is 0 doesn't mean the other has to be 0. It's actually the gradient of the potential, how quickly the potential changes, that gives you the gravitational field strength.